Good afternoon, students. This is our second lesson of the day. In the morning, we did discuss the Hess law of constant summation. We drew the energy cycle diagram and used it to calculate the enthalpy changes that occur in the formation during combustion of various constituent elements. This afternoon, I want us to look at another subtopic, that is relationship between heat of solution, enthalpy of hydration, and lattice energy. Now, just to begin with, what is lattice energy? Lattice energy is the energy released when an ionic compound is formed from its infinitely separate gaseous atoms. When an ionic compound is formed from its infinitely separate gaseous atoms, bond formation takes place in that case where ions combine to form a compound. Then, what is hydration energy? Hydration energy is the energy released when one mole of a gaseous ions interact with the water molecules to form a solution of hydrated salt. The heat of solution we did discuss in our last lesson, and we talked about the molar heat of solution of various substances like sodium nitrate, ammonium nitrate, and looked at the heat changes that occurs when a given amount of solute dissolved directly in a solvent. Energy involved in the separation of solid particles in an ionic compound into gaseous ions is the opposite of lattice energy. That is, if we have ionic compound, for example, sodium or potassium chloride, sodium chloride or potassium chloride, for hydration to take place, there must be breaking of the lattice energy. And the bond breaking, as you know, is normally endothermic. Therefore, given the lattice energies, that's for the bond formation when ions combine to form ionic compounds, given lattice energies is negative, which is exothermic process, then bond breaking, the breaking of lattice energy, formation of lattice energy during bond breaking becomes an endothermic process. Therefore, in the bond breaking during dissolving of an ionic compound to form the gaseous ions in any given ionic compound, it becomes an endothermic process. What happens when we dissolve substances in solvents? For example, dissolving of any ionic compound in a solvent will take place in two steps. Step 1 will always involve separation of gaseous particles into gaseous ions. Involves weakening of lattice energy. The lattice energy is what holds the potassium ion and chloride ion in the potassium chloride. Therefore, before hydration occurs, the ions that forms the ionic compounds, for example in potassium chloride, must be separated. And breaking of these bonds becomes an endothermic process. Then, after breaking the ions to form their gaseous forms, then solvation or dissolution. Now the gaseous ions dissolve or interact with the solvent molecules. We say it involves interaction of solvent molecules and the gaseous ions of the solute. And that also takes place in steps. The gaseous ion of potassium will interact with the water molecules to form a solution of potassium ions. At the same time, the chloride ions will also interact with the water molecules that act now as a solvent to form the aqueous solution of chloride ions. Bond formation, as we have mentioned, is an exothermic process, and therefore, to determine the heat of solution, the enthalpy of solution, will relate the three as heat of solution or enthalpy of solution is given here by the lattice energy plus the hydration energy. The hydration energy is an exothermic process, and therefore we can use symbols to present the enthalpy of solution given by the lattice energy plus the enthalpy of hydration. Given, for example, as shown in the table, the enthalpy of hydration of various ions, for example, potassium ion, chloride ion, sodium ion, and magnesium ion, and the lattice energies for the various compounds when we break the potassium chloride, sodium chloride, and magnesium chloride to form their gaseous ions. Given their bond energies, then we can use it to determine the enthalpy of solution of any given compound. An example, we look at how to calculate the enthalpy of solution of sodium chloride. At the same time, you can be asked to determine the enthalpy of solution of magnesium chloride. From the tables, we can also comfortably determine the enthalpy of solution of potassium chloride. But for this case, let's use the enthalpy of solution of sodium chloride as an example. Sodium chloride solid must first undergo an intermediate state where the bond energies, the lattice energy that is holding the two ions together, are broken until they become free in gaseous state. And therefore, the lattice energy here for the formation of gaseous sodium ion and chloride ion, then given the hydration, the energy for the hydration of sodium, independently of that one of chlorine, we can be able to get the enthalpy of solution if sodium chloride salt is dissolved directly in water. Let's apply this. The enthalpy of solution is given by the enthalpy lattice plus the enthalpy hydration. In this case, the enthalpy lattice for sodium chloride, to convert them to the gaseous state, is taken from the table. That is 781. We say from the definition, the lattice, when the ions combine, is an exothermic process. But in calculation, we are now breaking the ionic bond that exists between the constituent elements to convert them into the gaseous, to break them in order for them to become free. And when bond breaking takes place, it is an endothermic process, and that energy that is lost during the bond breaking is equal to that was used in the formation of sodium chloride, the lattice. And therefore, we take the absolute value, that is 781 negative, we take it to be a positive because we are now breaking the bond. Therefore, it becomes 781 plus the hydration energy. When sodium chloride dissolves in water, the hydration process, after the definition we mentioned, that it is an exothermic process. And therefore, 781 plus negative 774 plus minus becomes a minus. Therefore, the value obtained here becomes plus 7 kilojoules per mole. The information in this above energy cycle diagram can also be presented on an energy level diagram. Just an example. On an energy level diagram, we talked about having the y-axis energy content, which is always in kilojoules per mole. Then we have the reaction path or the reaction course. The formation, the lattice energy for the conversion of the sodium chloride into gaseous ions is an endothermic process. The enthalpy there is positive. Therefore, the reactant, that sodium chloride, appears below the gaseous ions. When they undergo hydration to form aqueous solution, it was an hydration process, we say, is an exothermic process. Therefore, you see the arrow facing down. The enthalpy of solution of sodium chloride, we have obtained a positive value of plus 7 kilojoules per mole. Therefore, when it is a plus, then it is an endothermic process. We use an arrow facing upward. Students, during your own time, I want you to go and try to determine the following: the enthalpy of solution of magnesium chloride and enthalpy of solution of potassium chloride. Given the values on the table, I feel you should now be able to obtain the enthalpy of solution of the two compounds. Welcome next time for another lesson. For today, let me conclude by saying thank you for giving me your attention toward the lesson. Have a good evening.